So when I teach the medical students and the residents here about blood banking and transfusion for blood products and things like that, we usually follow almost always the same methodology. Okay, we have to talk about the blood group antigens, what are they, how they present, things like that. Then we introduce the concept of testing, how to test, when to test, who to test, what the test result means, and what is the management. And then we have the indication and transfusion-related reaction. So I think now that probably it's the best way first to introduce the concepts of testing as a general idea, and then introduce the antigenic determinants in order to bring more clarity about how these antigens work. So let me start first with the direct Coombs reaction, which we use to detect autoantibodies against erythrocytes causing autoimmune hemolytic anemias. Now, since we are going to talk about antigens which are insoluble, the reactions that we are going to explore is called agglutination. So this can be due to the warm agglutinin or a hot agglutinin, and as you can see, I'm going to show you how exactly we are going to come to these conclusions. First, we have to talk about the Coombs reagent and what is the Coombs reagent. So if we have a normal serum from any person, it will contain all sorts of antibodies in it, which are proteins. So we can take these proteins, we put it in mouse, and the mouse is going to create anti-human antibodies or anti-human globulins, something that we call a Coombs reagent, and they will bind like this, the green ones. Then we have erythrocyte, and this erythrocyte has numerous proteins on their surface, and we usually have a restricted immune response towards these antigens, so we don't make autoantibodies. But if you do make an autoantibodies, they will actually cover the surface. These are the browns ones. They're going to cover the surface of this erythrocyte. So now, if we add the Coombs reagent, it will be able to actually cross-link, the Fc fragments of these autoantibodies, and as a whole, the entire reaction is going to agglutinate. It's going to give you this very granular reaction at the bottom of the plate. Now, if that agglutination happens at a low temperature, okay, then we are calling this cold agglutinin, and if it requires a higher temperature, we call it a warm agglutinin. Okay, so this is the principle of direct Coombs test.